Hey you guys, hopefully you're doing great. I'll be running around trying to take care of graduation, so you will definitely need a calculator. For today, you're going to need a graphics calculator. We're going to graph things, we're going to do scatter plot on these things, and then what we're going to do is come up with a function, okay? So today it is functions and 6, 8, oh boy, we're almost there, huh? Okay, so first of all, let's graph this. So I've tried to help us out. So make a scatter plot. So it's a spring. Here's the weight of the spring, and here's how long it will be stretched on the different weights, okay? So let's see, we've got a scatter plot of 4 and about 30.6, about there, 5 and about 32, maybe there, 6 and about 33, maybe there, 7 about 34 point something, 8 and about 36, 9 and about 37, and 10 about 39. Okay, so then I look at this. Okay, which one is it? So I've got my notes, and I got my family, right? Then look, maybe linear, but I don't think it's linear. It's definitely not quadratic. It might be a square root. In fact, the book tries to tell us that it happens to be a square root function, okay? If you look at what the book does in their illustration, it looks like a square root graph, okay? It's got a little bit of a curvature, okay? So if we're going to go ahead and figure out which one it is, again, if we think it's going to be a square root graph, a f of x equals some square root graph, let's see if we can find that. So first of all, let's go ahead and go into our stat button, okay, and calculate. Now what we're looking for is a square root, okay? And so what we can do is exponential, power regression, logistics, sine. So I don't really see a square root graph on this, okay? So all they're saying at this point is what kind of graph it is, and it appears to be, okay? Now, if I want to put it in the calculator, what I could do, let's go back to calculate, edit, right? I'll clear, and I'll get all sorts of stuff in here. Clear. Clear. Okay, so let's put it in. I go 4, enter, 5, enter, 6, 7, 8, 9, 10, right? 30.6, 32, 33.4, 34.8. Hey, thank you so much. Thank you. 34.8, 36.8, no, 36.2, my bad. 37.6 and 39. Okay, now we didn't have a quadratic, but I do know that that's like a 1/2 power. So let's try a few things. Let's go back into stat, calculate, okay? Quadratic, definitely not quadratic. Well, maybe we could do quadratic. It might give us an upside down quadratic. Cubic, quartic, linear regression, natural log, exponential regression, no. Power, no. So it could be a log, but we haven't talked about log. But let's go ahead at this point and just call it a linear regression because it almost looks straight, okay? So if I call it linear regression, all right, remember how we do this? I'm going to go linear regression. I'm going to go L1, comma, L2. So I get an answer. Oh, okay, that worked out pretty good. So equation y equals, I get a 1.4 for A, and B is a 25. I'm going to get a 1.4x plus 25, all right? Now, can we test it? How good is R? So let's test it. So looking for this R squared available. How good is it? So let's test it. Okay, to go to a test. We're going to go back, and I think my tests are back into stat. Go to my test, and I'm testing my linear regression in this case, right? Sample, go all the way down. Linear regression test, okay, right there. Boom. Everything looks good. List 1, list 2. Calculate. Boom, there we go. Okay, now I'm looking for this R squared, okay? R squared is 1. Wow, no kidding. We picked the right one. Because if R squared equals 1, of course you get to 1 the better. So the book calls it a square root graph, but you know what? Oh no, I was looking at the wrong one. This one's definitely linear. Definitely linear. Okay, it's got to be because I've got to test if r squared is 1. Definitely linear. It's not a square root graph at all. It is definitely linear. Okay, good. I picked the right one. Whew. Okay. Example 2. Okay. Ages of a tree. All right. So ages of a tree. Let's see what we get. So we got 1 point. We got diameter and age. So as the tree gets bigger every year, right, the diameter increases. So 1.6 is about here and 2 years. 3.6 is maybe here and 3. 6.4 is maybe here and a height of 4. 1, 2, 3, 4. 10, 8, 10's about here, and 5. 1, 2, 3, 4, 5. Okay. 14, 10, 12, 14.4, and 7. 1, 2, 4, 5, 6, 7, and 25. 10, 12, 14, 16, 18, 20, 22, 24, 25 is about here, and about, 8. 25.5 and about 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Alright, so that could be a square root graph, alright? So, we're not going to be able to get an equation on this, I don't think, but it is going to be y equals some square root graph. Let me check real quick. I don't remember that being in there. Let's go to stat, calculate, quadratic. We could do it as a cube, as a quadratic. We could do it as a quadratic. We could do it as an exponential, but nope. Power, nope. I definitely could do a log, but you guys don't know how to do a log yet. So let's try. Let's do quadratic. It might work for our quadratic, okay? So we'll try our quadratic, okay? Enter. So first of all, let's go back to calculate, right? We got to go to stat. Stat. Let's put these numbers in, okay? Stat. Go to stat. Let's show it again. Stat. Quit. Go to clear. Go to stat. Let's go to calculate. Nope, not yet. I'm sorry. Edit. Got to put the numbers in. My bad. Clear. 1.6, 3.6, 6.4, 10, 14.4, 19.6, 25.6. Okay. Other list 2, 3, 4, 5, 6, 7, 8. Okay. And let's go ahead and go to calculate. I'm going to go to second. I'm going to go to stat. Go to my stat. Calculate. Let's try a quadratic. It's the closest thing we're going to get to a square root graph. Okay, because it's the inverse of that. And let's try list 1, comma, list 2, right? Okay, so it appears like we're going to get a y equals a 0.0058x squared plus about a 0.4x plus a 1.54. Okay, now we didn't have a square root graph, so we used a quadratic instead. I used a y. I used an x squared. So how good is it? I don't know. Let's test it. How good is this? I have no clue how good this is because I just grabbed one. So let's go to back to stat. Remember that? Go to my tests. And I've got to do a quadratic test, right? Let's try a z-test. Nope. I'll do a z-test. Quit. Back to stat. Calc test. Let's try a t-test. Nope. Let's go to stat. What test do I want to do? Interval. Nope. Nope. To sample interval. Maybe try this one. Nope. Boy, I don't have the right test, do I? Alright. We're not going to get this one to test, but I got an equation, alright? Darn, we need better calculators. Okay, turn the page. Alright, last one. The zoologist is monitoring the size of a herd of buffalo in the years since the herd was released to the wild. Okay, time. We've got 5, 6, 7. So these are the years, and this is the population. So again, let's do a scatter plot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So year 5 is about 124. Okay, that's right about there. Year 6, 160, or I'm sorry, 150. 7 is 185, so let's see, that's 175. 185 might be about there. 8 is 213. 13, maybe there. 9 is 261. And then 10 is 322. Ooh, that definitely looks like that was quadratic. What does the book want to call it? I'm just curious. What does the book call the buffalo one? Exponential. Okay, let's try the exponential. They think it's going to grow exponentially. Alright, let's try exponential one, okay? So, exponential is some y equals ab to the x power, okay? Alright, let's check it out. So try it. And clear. So, go into stat. Got to put new data in, so let's edit that. Clear out my old list. Clear. And hey!
I'm returning a calculator.
Oh, you were awesome.
My calc final.
Yay! Thank you. I'm filming. You're on camera now.
Oh, shoot, I'm sorry.
Don't worry about it. You didn't know. Hey, everybody. That was Ranger. Say hi, Ranger.
Hey, is this your pre-calculus?
This will be
class?
period 4.
Okay.
Algebra 2. Yeah. Okay. Hopefully that gave you guys a chance to catch up. Okay. So here we go. Because I will be with Ranger while you guys are listening to this. Okay, here we go. Thanks, Ranger. 5, 6, 7, 8, 9, 10. Okay, and put the other ones in. 124, 150, 185, 213, 261, and 322. Okay. So calculus, or the book seems to think it's exponential, right? Kind of looks exponential to me. It's got that growth there. So let's try it. Okay, so I'm going to go to stat again, and I want to put some new numbers in. So I'm going to clear my list. Let's put new ones in. Okay, 5, enter, 6, enter, whoops, 7, 8, 9, and 10 for list 1. List 2, 124, 150, 185, 213, 261, and 322. Okay. Now, the book thinks it's exponential, so let's go back to stat. Let's go to calculate and choose exponential. Where's exponential on here? There's exponential right there. Exponential, reg, number 10. Exponential reg, so we go there. List 1, same thing. List 1, comma, list 2. Alright, so the given form of AX, AB to the X. So my answer is going to be a Y equals a 48 point, we'll round that to 6, times a 1.2 to the X power. I'm round a little bit, okay? Alright, so that's my equation. Now, I'm going to use my experiment for 15 years, and that's my time, right? So I can rewrite this as P for population, 48.6 times a 1.2 to the T. And it actually kind of helps to rewrite it so that you've got it in the right variables, like P for population, buffalo population, T for years. So now let's put the 15 in for T, right? So put the 15 right there. So buffalo population for 15 years is going to be 48.6 times a 1.2 to the 15th power. 48.6 times a 1.2 to the 15th. and I got about a 748.78 buffaloes, but you can't have 0.78, so I'm just going to round, right? Can't have 0.78 buffaloes, so I'm going to round that up to 749 buffalo. Okay, so real quick recap. What are we doing? Okay, so first of all, let's put a recap here. What are we doing? One, we're doing a scatter plot. And the reason we want to do a scatter plot is we're wondering, okay, well, what shape is it? Okay, so we look, do a scatter plot so we get an idea of which one we're going to do, okay? So then after we get a scatter plot, we get the general shape, right? We're going to enter the data. So we're going to go to Stat, we're going to go to Edit, we're going to enter data, right? Okay, so then after you enter your data, then you're going to go again to Stat. You're going to go to Calculate, right? Because you've got to figure out which one. But then you have to choose. Is it going to be a linear, a quadratic, exponential, square root? We probably don't want to pick this because we don't really have a square root function on our calculator. So you got to figure out which one. We could use the log functions, but you guys don't know how to do a log. Anyhow, so you got to pick which one you want, right? So then the next thing you do is step 4. You should just go ahead and calculate, and you get your equation. So then you calculate that. Don't forget you've got to put it in. Like it might be, let's say, quad reg. I'm just giving you an example. You got to go list 1, L1, comma L2, and you get your answer. Okay. Then the fifth thing you're going to do is actually after you get your answer, you've got to write your equation. So then write the equation. Now, if you're completely confused, give it a try. Give it a try. I'll be back tomorrow. We can look at this tomorrow, okay? So, Mr. Johnson's here to help. Please don't waste the period. Do not leave. Hear me? Do not leave the classroom. If you need to use pass, ask Mr. Johnson. Be respectful and be good.